Cool. Okay. I guess we can go ahead and get started. Hi, everyone. My name is Lindia. I'm a third-year PhD student. I work with Graham. And today is the Linguistics and Computational Linguistics lecture, or more of like a really fast tour because these are really big fields and I only have like 80-ish minutes to cover stuff. So I'll just go ahead and jump right in. So obviously this is an NLP class, but all of the data that you're dealing with is some representation of language. And we haven't really talked about like what is language, so that's kind of a little bit of what I'll be touching on in this lecture. Linguistics is the scientific study of language, its structure, and its use. Within linguistics, there's theoretical linguistics, which tries to find a general theory to explain the structure of language, or some framework in which we can describe language generally. Notice here that I said language and not a particular language, because while there are certain like specific rules that may govern the structure of individual languages, what we're really after is a general theory that encompasses all natural languages. This includes things that are spoken as well as signed. And now insights from theoretical linguistics can also inform more applied research. So this will be things like questions that concern linguistic variation within speakers across a single language. So like why do Indian English speakers say things in certain ways versus Singaporean English, British English, American English? How do we describe these differences? How can we explain them? Another question you may ask is, how are the linguistic structures within and across languages actually processed by the brain? This is actually of great interest to a lot of people in machine learning as well. And finally, how do people acquire a new language at different stages of their life? So when you're a child, how are you able to acquire like many languages at once? Whereas when you're 50 and you're trying to learn, I don't know, Spanish, and you've only learned English for like the first 50 years of your life, why is that much harder than when you're 6? So why should you care as an NLP practitioner? Because these days with large language models, you probably are like, well, syntactic theory means nothing to me. I just put in a bunch of text into a large language model, it processes it however it processes it, and it gets it right. Well, I would argue at minimum, knowing at least like what linguistics studies and the different ways you can look at linguistic data allows you to understand your data more thoroughly. And this is especially useful when you're characterizing certain failure modes. So like in your second assignment, we had you guys do an analysis of like maybe what types of questions are harder for your system to answer. And you could have done some analysis on like maybe certain wordings or structures in your questions made your systems fail more than others. It also gives you interesting test cases and frameworks to explore. Linguists have been thinking for a long time, like what examples will break their theory versus which ones like actually work. And these are also interesting cases to test your models on. I think more recently with large language models, people have been trying to figure out ways how to make them more efficient, smaller, use less data, and we can motivate data efficient methods with knowledge from things like language acquisition studies, like how do children learn language with much fewer exposure to like words and tokens than models that require trillions and trillions of tokens in their training data. And finally, these days, people are making lots of claims about how NLP models or systems are like similar or dissimilar to humans. And if you want to make those comparisons, you need to at least be aware of what theories people have been thinking about and how human language is actually processed and structured, even if you may not agree with certain theories. And all of that aside, I think that linguistics is just fun. You don't really need like an engineering reason to study things. So I hope that if some of this information is new to you and you find it interesting, that you're able to spend some time on your own thinking about these things. Oh, yes. Yeah. Okay. So as a roadmap of this lecture, I'm basically going to be doing a brief overview of major subfields and coverage of these topics. For each topic group, we're going to go over main concepts and things that people ask, previous or current computational approaches, and then applications to NLP. And of course, because there's a lot in linguistics, like people study these things for like centuries, and there's only 80 minutes, this might be very dense, so apologies in advance. So here are the major subfields that I'll be covering, going in order from bottom to top and increasing abstraction of the structures that each subfield studies. So at the very bottom, we have phonetics, which is the study of individual speech sounds and sign gestures. Then we have phonology, which is how languages organize these sounds and gestures. Then moving on to how words are formed, and then we take words, we create phrases and sentences. How do we structure those? Then how do we attribute meaning to different linguistic utterances? And then finally, combining all these things with context is pragmatics. So in that slide, I kind of showed you very like discrete levels of abstraction, but it's really important to note that this is more of a gradient. A lot of different levels of abstraction interact with other levels of abstraction. So we have things like prosody and inflection that might tell you something about the context of what you're saying. We have morphosyntax, which is the interface between morphology and syntax. And then there's the aptly named syntax semantics interface. And like, what is even really the difference between semantics and pragmatics? Where do we draw that line? All these things are very fuzzy. So even though I'm going to be going through these things very discreetly and in order, keep in mind that the boundaries aren't as clear cut as they are in this lecture. So the things I'll be covering are the colored ones on the right with the like more applied subfields. I don't have time for these, but these are very important. And I think they're growing in, I guess, awareness in the broader like engineering NLP community in terms of like interest. So we have things like neurolinguistics, psycholinguistics, sociolinguistics is a huge one, especially for ethical NLP. Like how are we serving different communities? How do their inputs differ from like the standard input that you would find like on web corpora? Things like linguistic typology, how do languages differ, historical linguistics, etc. But the one thing about all of these is that we can use computational methods to explore questions within and across all these subfields. So like I said, I'll be covering the things in color, and I'm chunking them into three major parts. First being sound and gesture, then subwords and constituents, and then meaning and intent. So let's start from the bottom with sound and gesture. So phonetics is the study of speech sounds in the case of spoken languages or gestures in the case of sign languages. And we can further divide phonetics into three categories or three subfields, sub-subfields. How we produce these sounds or gestures, articulatory phonetics, how we actually perceive these sounds, auditory, and then how we can analyze their waveforms, which is acoustic phonetics. So phones are what we call the individual speech sounds or gestures within a language. So an example of this would be like the p sound in the English word pat or the r sound in right. But as we can clearly see in that second example with right, text is often not a one-to-one mapping between the characters or how something is spelled and how you actually sound it out. This is even more clear with scripts that are logographics with little indication of how words are pronounced. So things like Chinese characters. Even though maybe some radicals might tell you or give you a hint as to how something might be pronounced, this is very unclear for many characters. Other ways of spelling things are very consistent. So the exact pronunciation of how something may be pronounced can often be determined straight from how it's spelled. So something like the Japanese kana, Spanish and Hindi. And then others, like English, have a general relationship between spelling form and how it sounded out, though we often have irregular cases. So like English right, WR is also pronounced the same way as right, like turn right. And French is obviously an infamous example of something that is very unclear to a non-native French speaker and writer on how to pronounce. So given that all of these ways of writing things are very inconsistent, we need a way to represent sound in a one-to-one mapping for linguists when we're comparing languages. And they use the International Phonetic Alphabet, or the IPA, not the beer. And you can see in brackets, that is IPA spelled out in IPA. In the like white handout thing, we basically have groups of sounds and their corresponding characters and exactly how they would be pronounced. One cool computational tool, which is actually out of CMU by David Mortensen, is Epitran, which is a library for transliterating orthographic text, or like how things are standardly spelled into IPA. So I just showed you like how we would represent sounds in text, but how are these sounds actually produced by humans? And that is the study of articulatory phonetics. So when we create sounds, we basically have like a pathway of air from our lungs out to our mouth. And the way that this air is either constricted or flows through the vocal tract is how the sound is created. So based on how the air is either like trapped, restricted, or changed by like things in the mouth, nose, and throat, we'll get different sounds. And we can categorize these sounds based on how these modifications occur. So vowels are produced without any restriction in the vocal tract. Consonants are produced with either partial or full restriction. And then like fun little semivowels are kind of in between a consonant and a vowel. These are sounds like ya and la, which are like somewhat constricted, somewhat free. So we kind of just put them in between. So for consonants and vowels, we can categorize consonants specifically based on their place and manner of articulation. I'll get into that a little bit, as well as how whether they are voiced or voiceless. So place is basically where that air restriction is happening, and manner is how that restriction is happening. So for example, if I were to restrict air at my mouth and close it fully, I could make a sound like p or ba. And that is like the letters in the top left part of this chart. Now you can see that there's two sounds in that one box for plosive and bilabial. Plosive meaning it's a full stop, bilabial meaning it's happening at the mouth. But the difference between these two sounds is whether I have a vibration here. So p has no vibration, but b requires one. So b is voiced and p is voiceless. As for vowels, they can be categorized based on three things: the position of the tongue, whether it is in the front of the mouth or the back of the mouth, how open your mouth is, whether it's like closed or open, and then how rounded your lips are. So you can see in this graphic here, how you can look at this is imagine like someone took a saw and like cut me straight this way and then looked at me this way. So like that diagonal here would be like the front of my mouth, and that straight line in the back would be the back of my mouth. That's how you can like interpret this chart very easily. And vowels are typically voiced, but voiceless vowels do actually exist, just not in English. Okay, so we've done like a quick rundown of phonetics. Now let's move on to phonology. So in phonetics, we dealt with like the actual sounds themselves, but in phonology, we're dealing with the categorization of these sounds, or in sign languages, equivalent gestures. Now, we were talking about like physical properties of sounds, like how things are created when we like push air through our vocal tract. But this is kind of outside of the context of how these sounds occur in a language. Whereas in phonology, we're looking at the abstract rules or constraints that govern the interactions of sounds in a language. So these will be like the types of questions that someone would ask as a phonologist are things like, what sounds are meaningfully distinct in a language? How are sounds organized into syllables in a language? And then what rules govern allowable sequences of sounds? So quick recap of a definition. Like I said before, phones are individual speech sounds. But now we have phonemes, which are, instead of like the actual sound itself, these are perceptually distinct units of sounds. And phonemes are units that can distinguish one word from another. So as an example, we have two words here, pit and lit. The p sound is perceptually distinct from the l sound. So p and l are separate phonemes. And if you take all of the different perceptually distinct units of sound in a language, we have a phoneme inventory. And different languages will have different phoneme inventories. So like a little psycholinguistic fun fact is when you're a baby, they've done these tests on infants where they give them a pacifier, and they notice that like children, when they perceive like a new stimulus, they'll like suck more on the pacifier like faster. So they took all these babies and they played a bunch of like speech sounds to them, and they could tell like the babies can distinguish all variants of speech sounds. But as you grow older and you adapt to your native language, your brain efficiently just decides mainly distinguishes between the ones that are actually distinct in your language. So this is why, like, for native English speakers who don't know any tonal languages, they find it very difficult to like pick up Mandarin, for example, which does have distinction in tone. Of course, we can still relearn it. It's just much harder when you've lost all that like neuroplasticity as a baby. Okay, so as an example for how phonemes may work, consider the two words spat and pat in English. So there's P sounds here, but they're actually different. So if you put your hand in front of your mouth and you say spat, you'll notice that there's either no like puff of air on your hand or just like a very faint one. Now, if you say pat, you're gonna have a bigger puff of air, right? So spat uses a P sound with no aspiration. That's the no puff of air. Whereas pat, you have a puff of air. So these, when you look at the spectrograms as well, these are two actually like different waveforms. But if we were to change like that P without the puff and the P with the puff to get like in different places, like we took a waveform of someone saying spat and we replaced it with the puff in the waveform and played it back to them, it wouldn't change the meaning of the word that they're hearing. So the P with the puff of air and the P without the puff of air are the same phoneme, or they fall under that same umbrella. And we call these two different sounds, which are under the same perceptual unit, allophones. However, in other languages, they would actually distinguish between the P with no puff of air and the P with the puff, like in Thai. So in Thai's phoneme inventory, that would include a phoneme for both the puffless P and the puffful P. So we've gone over what phonemes are, but like as we saw in the pat versus spat example, depending on the surrounding sounds of that P phoneme, it can be pronounced differently. And this can be expressed through phonological rules. So in the case of spat and pat, the way that that P phoneme is pronounced is determined by the sounds that surround it, which we refer to as its environment. How do we come up with these rules? Well, we basically make a bunch of observations about the distributions of these sounds. So if we were to look at a bunch of English, spoken English, we would find that generally aspiration or that puff only occurs when P is at the beginning of a stressed syllable. And if we were to look even more at some other sounds, we would notice that this happens to sounds like t and k. So from these observations, we can make a rule that these sounds, which when grouped together are actually unvoiced stops, will be aspirated or have that puff of air at the beginning of a stressed syllable, and it will be unaspirated otherwise. So what are some computational applications of phonetics and phonology? Here's just like a brief sampling of interesting papers. One really cool one that I enjoyed was automatic proto-language reconstruction. So we can like kind of trace back how languages have evolved over time and how they're related by looking at how the phonological changes have occurred across words and related languages. And some studies here have done that like automatically. Another one is cognitive models of human speech production. So in this paper from Berkeley, they basically trained an unsupervised speech synthesis model that produces speech with human-like articulatory gestures using like electrical measurements from people producing different types of sounds. We can also use like these taxonomies from phonetics and phonology for evaluation, like asking whether phone embeddings from neural models actually encode phonological relations. And then also from this work with some people from CMU, actually, they tried incorporating different phonetic information into word embeddings, and then seeing if this information can be used to help apply to tasks like cognate or loanword detection, multilingual named entity recognition, language ID, etc. Okay, so now we're moving on to subwords and constituents. But before I move on, does anyone have any questions? No. Okay. So morphology is the study of word formation and structure. And if you've like armchair philosophized sometimes, or you've like said a word over and over again, you're like, oh, what is a word? Like, do words exist? Or is it all fake? I'm not going to answer that question. These are questions that like linguists have been thinking about for a long time. If you ask a really opinionated linguist, they could probably like talk to you about this for hours, and I'm not going to do that. So for now, we're just going to gloss over this and we're going to go with our intuition for what a word is. So just think to yourself, like, if someone asked me on the street what a word is, like, I'm just going to give them my intuition. So with that, we'll continue. Words are formed from linguistic units called morphemes. And morphemes are defined as the smallest meaningful linguistic unit. So for the word morphology, for example, we can split it into morph, which is the root that means form or shape, and then ology, which is study of. Same thing with like phonology, for example. Now, most of the examples that I'll be using in this lecture are in English, though if any of you guys know another language or have like read actual linguistics papers, you'll realize that English morphology is like extremely boring. So if you want like more fun morphology, you can check out like polysynthetic languages, including many indigenous American languages, for more fun examples. Okay, so for the most part, we can categorize morphemes into broad categories using these following properties. First, you can ask, can the morpheme occur on its own? If it can, then it's free, and if not, then it's bound. So for example, in dogs, we can split it to dog and then the plural marker s. Dog is free because it can occur on its own. You'll see like dog as its own word, but s you don't. So it's bound to whatever it's attached to. A fun like little tidbit is that there are these things called cranberry morphemes where like, oh, like I can split cranberry into cran and berry occurs on its own, but what the hell does cran mean? We don't know. So that's actually an artifact of a lot of like historical change in languages. Cran doesn't have its own meaning and it also doesn't occur on its own. So we classify those types of morphemes as cranberry morphemes. Another way we can categorize morphemes is whether it comprises the quote, main meaning of the word. And if it does, it's the root. And if it's not, it's the affix. So clearly in dogs, because we're just talking about more than one dog, like most of the meaning is attached to dog, so it's the root. And the S is the affix. But we can also have words that don't really have like any free morpheme as well. So like multilingual, each of these are kind of bound. But we still have a root, like language is comprising like the main thing in that word, whereas multi and ul are kind of modifying it. So there are a couple of processes in morphology. The first one I'll be talking about is called inflection. And this basically creates a new form of the same word. In this process, the main concept or meaning of the word is remaining the same. And what this typically does is it changes a grammatical feature of the word. So it can change the number, like in the dog example, we have a singular noun. Now we attach an S and now it's a plural noun. We can also change the person. So I run is first person it's a verb in first person. He runs is a verb in third person by attaching that S. We can also change tense or like when that event is occurring. So I climb can be a verb in the present tense versus I climbed is a verb in the past tense, et cetera, et cetera. So inflection, while it keeps it basically creates a new form of the same word, we can also have word formation, which creates new words. And there's two processes in word formation, derivation and compounding. So derivation is a process that basically creates a semantically related new word, but it operates on a base form, often through processes like affixation, which is like attaching different morphemes to that base. In this case, the main concept or meaning of the word will change. And oftentimes we can have the part of speech change, but this is not always the case. So for a couple of examples, we have a verb to teach. If I attach now I'm talking about someone who teaches, and that's a noun. We can talk about someone who is intense, or you can talk about a process of making something more intense by adding ify, intensify. We can also go from an adjective to an adverb by attaching like ly, so easy to easily. But as an example of something where the part of speech doesn't change, we can have lucky to unlucky. Another process of word formation is compounding. So this is a process that creates a semantically related new word by combining different words together. So like blackbird, we have two separate words, we've just shoved them together. Ice cream, like it's basically one word, it's just we wrote it with a space in between because it's not like we're describing something with both ice and cream, we're kind of creating a new concept of like really cold whipped cream that is ice-y, and then skyscraper. And some languages are very, very productive in this compounding process. So like I have this, I don't think you can read it, so I'll read the description. This very long German word or compound that translates to cattle marking and beef labeling supervision duties delegation law. So like I said, English is very boring, but things like German, like this is so fun. So all of the examples that I've shown you guys are pretty simple. We've basically just taken a root and we've like shoved affixes onto them and like, wow, look, a different word. But not all morphological processes are going to be this straightforward. Like I said, English is very boring, but other languages have different processes that are more common. So apophony, this actually does occur in English. So going from singular tooth to teeth, that vowel in the middle has changed. That's very different from affixation, where we've just like added something onto the root. We've actually altered something within the root. Infixation, there's also a fun occurrence of this in English, which is expletive infixation. I won't say it because this lecture is recorded, but you can maybe read it potentially. Then there's transfixation, as with Arabic and Hebrew roots, if you guys are familiar. So I have this example here where KTB is the root, but we actually change things in between those consonants. But KTB, I think, as the root itself, either means something like book or to write or writing. And changing the things like in it and surrounding it will change the form of like what the word actually means, like he wrote, she wrote, I wrote, etc. There's also a process called reduplication, which does what it sounds like. It duplicates a part of the word. So in Indonesian, we have this word berjalan, which means to walk. But if I like copy this part of the word, it means to stroll. And then there are other processes as well. So lots of fun things you can do to create new words. So computationally, what do we do in morphology? One thing that is pretty important, especially for understudied and endangered languages, is morphological analysis. So basically taking like some word and then breaking it down into its morphemes and then describing what each morpheme does. So the input of such an analyzer would be that word form, and then the output could be all possible morphological parses. Right. Sorry, lots of talking. Morphological analyzers are traditionally created using finite state transducers, or FSTs. And it's a two-step creation process. First, you have the lemma. So like, it's okay. So imagine the word, okay, here, bus. Bus is your lemma. And then a morphosyntactic description. So like, if I'm trying to describe buses or like more than one bus, it would be bus and then plural for that label. And then we map that to an intermediate form that represents like the canonical or like the usual way that the that label plural instantiates in that language. So in English, to make something plural, we'll usually attach an S to it, right? So we have bus plural to bus with an S attached. But as we all know, sometimes we have like irregularities. So in the case of plurals, like we don't say bus, we say buses. So we would need to map from that intermediate form to the actual surface form that we want here. And basically what an FSC does is it takes as input like that description and then puts out buses. But the nice thing about FSCs is that they're invertible. So we can use it as a generator or an analyzer. So I could also give it buses as input, and then it would give me bus plural as output. And some tools that you can do to create these analyzers are things like FOMA, REST FST, and then OpenFST. So like I said, these analyzers are traditionally created using FSTs, but more recently with the explosion of neural models and LLMs, these are increasingly being used. But that doesn't mean that FSTs are completely useless. We can also combine the two approaches. So for example, we can take an FST and combine it with a neural guesser if we are encountering word forms that we haven't seen before. We can also use FSTs to generate additional training data or artificial data to augment our neural models. And a shameless plug, I was part of this paper called Gloss LM, which basically takes a bunch of transcriptions from endangered languages and then outputs a form of morphological annotation. And we do this for many, many languages and focus specifically on 7 very low resource languages, including this language, which is Arapaho. So. Okay, so we've talked about words, we've talked about how words are formed. Now we can get into the fun thing of putting words together. Look at how we're like building all these little blocks of language together. It's so exciting. So syntax is the study of how words form phrases and sentences. And like the big question we ask are like, what are the principles governing these phrase and sentence structures within a language and then also across languages? So some different things that we consider in syntax include word order. So like, is your language subject, verb, object? Is it subject, object, verb? Things like agreement. How do the subject the main subject of the sentence agree with the verb of the sentence, and things like hierarchical structure, like what is modifying what in the sentence. And like a fun little example of some aspects of syntax in English is like this tweet that I always find really funny that says, "I'm so glad I never had to learn English as a foreign language. This looks like 9 consecutive nouns, like Beijing home price slide bans China property sector alarm." So you can take a minute to like figure out how to parse that. Yeah. So we've done a lot of categorization in linguistics. Linguists like categorizing things, and we're going to categorize words now. So these can be categorized based on their morphological, syntactic, and semantic properties. And then we can refer to these categories as things that you're very familiar with, parts of speech. So things like nouns, verbs, adjectives, etc. Now, maybe in like your English classes, or maybe in your like first like native language classes, you've been told things like, oh, a noun is a person, place, or thing, and a verb is like an action, and an adjective modifies a noun. But it's really not that simple. And this categorization is not very hard and fast across languages. For example, like some languages don't really make a huge distinction between certain types of verbs and adjectives. So while these categorizations are useful, they may not actually be like truly representative across all languages. So just keep that in mind. Don't take them for granted. And then among these parts of speech, we can further abstract over them into different categories like open class words. So these are classes where, or parts of speech where new items can be added over time with relative ease. So with slang, like new word alert, new word just dropped, Riz, right? Like, I mean, derived from charisma, but now it's kind of like used as its own word. It's an open class word, can be used as, I think, a noun and a verb. Like, he rizzed her up versus, oh, he's really got riz. And then there's closed class words, which are of much smaller number, and then it's really hard to add new items to them. So like, I've never seen in my life a new preposition appear, and I probably won't. There's only so many positions you can describe, and I think it would be really hard for people to pick up like a new preposition. Yeah. Oh, I have to move my video. Oh, not to the center. I can't find my cursor now. Well, it'll be there until I can figure it out. But based on a word acts in context, even if we've never seen it before, we can often infer its function and part of speech. As in like this poem here, which is like every linguistics class go-to example for part of speech. So like, "'Twas brillig and the slithy toves did gyre and gimble in the wave." Can someone like tell me what gyre and gimble are? Like, what are their parts of speech? Does anyone have a guess? Or maybe like wabe. What is wabe here? Like, what is the part? Yes. Yeah, it's a noun, right? It's the wabe. Like, what do you put? Yeah. Okay. Let me move my video. Oh, no. Oh, this is so embarrassing. Right. Okay. Cool. All right, so on the left, I have like the canonical open class parts of speech. And on the right, I have the canonical closed class parts of speech. And then I have this example sentence with each of these words annotated with their part of speech. So like, they had argued intensely, pronoun, auxiliary verb, verb, adverb, etc. Okay, so we've described words. Now let's do the fun thing where we put them together. We can form different types of phrases, and these are pretty straightforward. Here are some like very important phrases in English. First, we have the noun phrase. It contains a noun. It can also include a determiner and an adjectival modifier. So like, the old man is a noun phrase. So is old man, and so is man on its own, because the other two things are optional. We can also make prepositional phrases, which contains a preposition followed by a noun phrase. So like, on the shelf. Verb phrases contain a verb, and then optionally, or sometimes they require any noun phrase or prepositional phrase that needs to be filled in slots. as well as any like open things that are optional, and then also adverbial modifiers. So something like sold a car to me is a verb phrase. So one thing to note about syntax is that there are these units in sentences that kind of behave as a single unit. And I'll show you what this looks like in an example. So a constituent is like these continuous or contiguous groups of words that behave as like a single thing. And a crucial observation about these constituents is that we can replace units within them with smaller and smaller constituents of the same category all the way down to the word level. So here I have a sentence, Anthropic released a new language model. So let's take language model and replace it with like a smaller unit, like a single word. Anthropic released a new agent. Okay, cool. Now we can replace new agent with something else. Anthropic released a shrimp. And then we can also replace a shrimp with yet another word. Anthropic released AGI. So like all the way from a new language model to AGI, everything kind of like acts the same. We can swap out things for things of the same category. So this kind of idea is very important in context-free grammars. In linguistics specifically, phrase structure grammars. And phrase structure grammars were originally introduced by Noam Chomsky, I believe in Syntactic Structures 1957, which is actually a really great read for like learning how to make an argument in a very convincing way. I would actually recommend it to people here, even if you don't believe in generative linguistics. But his phrasing is, a phrase structure grammar is defined by a finite vocabulary V and a finite set of strings, sigma, of initial strings in V, and a finite set F of rules of the form X to Y, where X and Y are strings in the vocabulary. So some very, very simplified example of phrase structure rules for English is that a sentence is comprised of a noun phrase followed by a verb phrase. And then within that noun phrase, we can have a determiner optionally, and then some noun phrase, subscript 1. And then that noun phrase further breaks down into an optional adjective phrase, a noun, and an optional prepositional phrase, and so on and so forth. So once we have all of these rules that describe how we can make sentences and their individual phrases within the sentences, we can generate lots and lots of sentences in English, including those that are syntactically like correct or proper, even if they don't actually have a real meaning. So a famous example that he brings up, or Chomsky brings up, is colorless green ideas sleep furiously. So to a native speaker or someone who is like very fluent in English, that actually like doesn't sound terrible. Like it's grammatically correct. It just doesn't really have much of a meaning. And speakers have intuitions for like what sounds acceptable in their language versus unacceptable or ungrammatical. But if you're like thinking, oh, well, if we could just enumerate all the rules of every language, then we kind of just solved syntax, right? Like this is way too simple. And yeah, you're right. That's why we're still doing this. Some phenomena are like really difficult to model in this fashion. And beyond like phrase structure grammars, we've like theoretical syntax has since expanded. So there are new frameworks like minimalism, other formalisms like HPSG, different cognitive linguistics approaches that are like very, very different from things like phrase structure grammars and minimalism, like construction grammar, etc. Nevertheless, like the ideas that came up with things like phrase structure grammars and CFGs are conceptually powerful, and they still remain influential today. So an important, and one of those influential things is the idea of hierarchical structure in syntax. And this is also appearing in all these other like theories that I mentioned. So we can represent how these phrase structures break down sentences by representing them in a tree, where the sentence node S is at the top, and then the leaves are the words in the sentence. So I think last year, instead of my Anthropic example, I had something about Beyonce releasing a new country album. So here's the tree for that sentence. And we can also use trees or these parses to represent syntactic ambiguity. When we have a sentence that could potentially be parsed in different ways, there will be different resulting trees for those parses. So a classic example is a sentence like, I saw a girl with a telescope. we can parse this in two different ways. So I saw a girl, like I have a telescope in my hand, I look through it and I see a girl. In this case, the prepositional phrase with a telescope modifies seeing. So that's one meaning of the sentence. Another meaning of the sentence is, I saw a girl who has a telescope or is by a telescope, in which case this prepositional phrase modifies girl. It attaches to the noun phrase as opposed to attaching to the verb phrase. So a little like next token prediction for you guys. While constituency trees, like these here, are based on constituency relations, what do you think dependency trees are based on? Can you do like a little analogy? Who wants to be like the language model that predicts the next token?
Dependency relations.
Wow, congrats. Dependency relations. Sometimes we refer to them as grammatical relations, and these relations are basically binary asymmetrical relations that connect the meanings of words and phrases. So these relations take the form like A to B, where A is the head and B is the dependent. We can have different types of relations. They can be like syntactic relations, semantic relations, morphological relations, but most frameworks focus on syntactic relations with the main verb serving as the root of all of the things in the tree. So these can be things like these like A to B's can be things like clausal relations, like for the verb, like what is the subject, what is the direct object, what is the indirect object. And they can also be things like modification. For a noun, like what is modifying the noun? Is it another noun? Is it an adjective? What is modifying the verb, etc. So here are some examples of dependency relations. As you can see, everything starts from a verb, and that's very different from the constituency parses that we saw that had an S at the top and then broke down into a noun phrase and a verb phrase. And all of these examples come from universal dependencies, which if you guys have been in NLP long enough are probably familiar with the name. So in an old task that I guess people don't really do for English anymore because we've solved English is POS tagging, syntactic parsing, and annotation. Like I said, these tasks used to be a really big deal, but not as much anymore, at least for high resource languages. But like morphological analysis, it's still a really valuable resource for people studying lower resource languages. And having like this wide range of linguistically annotated corpora over a ton of languages can enable us to do cross-linguistic studies. So some examples of corpora with these types of annotations. We have like the Brown corpus and COCA, or the Corpus of Contemporary American English. I believe both of those are annotated for part of speech tags. The Penn Tree Bank was hugely influential. And then there's also Google and Syntactic Ngrams, which has like those dependency relations I showed earlier. And then recently there's been this huge effort for universal dependencies to add like construction annotations on top of them over many, many languages. And there's still like a continual effort over this over the years. And another question that's more recent, I guess, other than just like, oh, can we annotate a bunch of corpora for like their part of speech or like the syntactic structure that each sentence takes? Knowledge of syntax and like these theories around syntax are like great test beds to see if things like large language models or even small statistical models of language are actually learning grammar as we understand it. So things like the targeted syntactic evaluation paradigm, where we're comparing the probability of like a grammatical sequence versus an ungrammatical one, is pretty popular in like the computational psycholinguistic space. Okay, now on to our final like big chunk, which is the meaning and intent portion. So semantics is the study of linguistic meaning. As we talked about earlier, we can study this at various levels. Like I was talking about how morphemes are like the smallest meaningful linguistic unit. We also have meanings of words. We can have meanings of sentences and so on and so forth. As we saw, like I just said, it often interacts with different components in morphology and syntax. And there's this like really interesting space within between syntax and semantics called the syntax-semantics interface, which kind of like investigates the relationship between the form of an utterance and its meaning? Like, how do those things interact? Like, does the actual underlying meaning change how you might want to actually put it in like in its surface form? Like, what syntactic form would it take? Now, much like, oh, is a word real? Is a word not real? Talking about like meaning very abstractly can veer very easily into philosophy of language, and I'm not going to be doing that today. It's very fun though if anyone wants to like talk to me about this. But we're going to stick to computationally relevant topics. But even then, we still have like limited time, though I think I'm going faster than I originally intended. So I'm gonna like not really touch things like propositional and first order logic. So to begin with, we can start with meanings of words, which is lexical semantics. So one important concept is this idea of a sense of a word, which is a distinct meaning of that word. But words can mean different things in different contexts. So they can have multiple semantically related senses. And we refer to this as word polysemy. So take, for example, run. I can use it in various ways, but they kind of all have this like related flavor. So I can say like, oh, I'm running an experiment, I'm running a race. Some candidates earlier this week ran for office. Can I run this idea by you, et cetera, et cetera. And when we talk about senses, we can also talk about how they relate to one another. A sense can we can talk about one word sense and it being the same or very, very close to another word's sense, or we can talk about how it's completely the opposite. That would be something like synonymy and antinomy. And okay, I always have trouble pronouncing those words. We can also talk about how like one is like a superset or a subset of another word. So like a greyhound is a type of dog. It is like a subset of all possible dogs. Or like a bird is a type of animal, etc. And we can also talk about like part-whole relations, like the Senate is part of the legislative branch of the US government, etc. Within NLP, one very influential database is WordNet, which basically groups a bunch of senses of different words in the English language. So what it did is it took content words like nouns and grouped them into sets of synonyms, and they refer to these as synsets. So you can't see this very clearly, but like those groupings with a ton of like at the like run and running and jump and parachuting and leap, hump, and damage, harm, and impairment, like those groups we're grouping together like these synsets, and then we link together the synsets through different relations like I talked about earlier. So like the subset, superset relations, or like the same opposite relations. Another thing that it does, it distinguishes between types or like common nouns and then instances of those types, where instances are always going to be the terminal nodes in these hierarchies. So for example, I would have as a type like president and then instance Obama, for example. Since the creation of WordNet, people have also created similar sets or databases in other languages. And it's also had influence beyond just NLP. So for those of you familiar with ImageNet, they actually base their hierarchy of images and concepts according to nouns in WordNet. A very influential idea that has come out of semantics that has been really popular in computational approaches is the idea of a distributional hypothesis. So what this basically states is that linguistic items that have similar distributions in like very large corpora will have similar meanings. And a popular quote that kind of sums this up that you may be familiar with is, "You shall know a word by the company it keeps." And this idea is the foundation for statistical approaches to lexical semantics. Can anyone like give me kind of like one very, very influential thing that came out of NLP that might be closely related to "you shall know a word by the company it keeps"? Maybe it's already on the slide, as I just realized. Okay. Word embeddings. So given a large corpus, we can form vector representations of words based on how, like, the statistical relationships and the distribution of occurrences between those words. And then we can show like these sense relations, like same, opposite, or like subset, superset, with things like vector arithmetic. And then with embeddings, we have both dense or static embeddings, where all of the same like surface forms are mapped to the same vector, which causes an issue with things like polysemy, right? Like if I have run for office versus like run a race, those have slightly different senses, but they're going to be mapped to the same vector. But we kind of can get around this issue with contextual embeddings because depending on the context in which that word is occurring in, we're going to have different representations. So that is like one very, very influential space within semantics is distributional semantics. Another important concept in semantics is this idea of compositionality. So like we saw in morphology, where we were basically taking different morphemes that mean different things and putting them together and getting this new meaning, much of natural language is compositional. So in sentences, we can also combine the meaning of different lexical items and the different phrasal constructions to create like the meaning of the sentence as a whole. And this process is very systematic in language. And we can determine the meaning of novel sentences that we hear. And similarly, we can generate these very novel sentences by taking different components of different things and putting them together. Now, it's still kind of an open question as to how well cognitive or models of language can actually do this. There's things like the ARC challenge, I think, that kind of deal with this issue of compositionality. And there have been a couple of studies kind of evaluating models' abilities to deal with compositional generalization, like in machine translation or just broadly in terms of like different syntactic structures. But there are also exceptions to compositionality. Not all meaning in language can just be determined by putting together different parts. So for example, we have things like idioms and figurative language, where like it's raining cats and dogs. Like there's no actual like instance of cats and dogs falling from the sky, but what it's trying to convey is that it's raining really hard. So in that case, like we don't actually have a compositional meaning in that scenario. And this is a challenge in applications like machine translation. And one really funny example is when Google Translate back in 2022 tried to translate the names of McDonald's food items in Chinese to English. And it came up with things like unsuspecting tyrant double-decker beef fort and full marks for grilled ham. So part of me kind of wishes that this like is never solved, because then we get like excellent examples like this. Another thing that is of concern in natural language processing is the idea of entailment and natural language inference. So one aspect of an expression's meaning is the truth conditions, or like the states of the world under which that expression would have to be satisfied for that to be true. So as an example, look at the sentence like Emmy is a cute cat. This sentence is only true if Emmy, this is Emmy, is in fact a cat, but it would be false if Emmy were to be a dog. And as you can see, like we had different statements that relate to that initial Emmy is a cute cat. And entailment is like one such relation. And basically what it is if A entails B, then B must be true if A is true. So in other words, that B statement is a truth condition of A. And to give more concrete examples, I consider the A sentence, Emmy is my adorable little orange cat, entails a couple of things. It entails that Emmy is a cat, Emmy is little, and Emmy is adorable. And these are all truth conditions for this. Like if Emmy were not a cat, then this sentence would not be true. So a couple of years ago, this like task of natural language inference, basically seeing if something is entailed or contradicted by statement, was pretty popular. Basically what it was is given a premise, or like A and that A to B relation, determine if a hypothesis B is entailed or contradicted by that premise. And there were a couple of data sets that were created to evaluate this, like SNLI, multi-NLI, SciTail, XNLI, etc. These days, like people aren't doing NLI for the sake of solving NLI, but it's still quite useful for other applications. So like, let's say you're generating a bunch of text from documents, and you want to be able to check if the text that you generate is factual or not. You can cast this in terms of entailment. Is the thing that you're generating entailed by the document, or is it contradicting it? You can also see if like two different news sources, for example, agree on a scenario in like fake news detection. Okay, so now moving on to pragmatics. What we've talked about here is kind of in isolation of the social context that we're using language in. But in reality, like language has much more to it than just the things that we say. It also embodies like, what is the social relation between you and I? What is like the broader social context we're having this conversation in? Like what's in our environment? Am I like pointing to things in the room? Are you aware of certain things that I'm aware of? So in pragmatics, there's a couple of things that we think about. First, how is language used in like broader social interactions? How does this context, either linguistic or non-linguistic, influence language use? And what do we actually intend to mean when we say something? And how does this influence its interpretation by listeners? One really influential theory within pragmatics is the speech act theory, which states like the meaning of an utterance is comprised not just of like what I literally say in the statement, but also the intended effect of the utterance on the listener. So like imagine you're at dinner, there's someone else and they have the salt shaker by them and you ask them, can you pass me the salt? Like you're not asking them literally, like, are you physically able to pass me the salt, right? You're requesting them to do that. So that is a speech act of requesting. Another one that I find like a little socially ambiguous is when you're like sitting in public transportation or like at an event and someone asks, do you mind if I sit next to you? Like if I say yes in the literal sense of if I mind that they sit next to me, like that actually means like, oh, I really mind, you should not sit there. But usually when I say yes, it's like oh, go ahead, like, yes, you can sit there. But another acceptable thing you could say is, oh, no, I don't mind at all. So these are kind of like the implicit social things that that are imbued in what we say, even though it's not literal in the things that we are actually speaking. So one concept in pragmatics is this idea of presupposition. And these are the implicit assumptions about the world that are present in discourse or in conversation. So for example, I showed you my cat earlier, and of course, everyone in the room thinks my cat is cute. And when I say that, I presuppose that I have a cat, right? Like it would be super strange for me to say everyone thinks my cat is cute if I don't actually have a cat. So that is the presupposition, one of the presuppositions of that statement. Presupposition, the presence of a presupposition can be triggered by certain lexical items or constructions in your utterance. So for example, if I say something like the King of France, the fact that I say the X has an implicit assumption that I'm referring to that one thing and that one thing actually exists. Another thing we can use that would trigger a presupposition is the use of affective. One example of this is like the word regret. So when I say, I regret staying up all night to watch the election, by saying regret X, it presupposes that I in fact like did do that thing. Another thing that is actually quite important in NLP is presuppositions in questions. So like in the question, which linguist invented the light bulb? This presupposes that a linguist actually did invent the light bulb, but we all know that's not the case. So when we have questions like this, these are actually like unanswerable because there's a false presupposition. Like nothing you would say could actually satisfy that question. And there's been studies on this on like QA data sets that actually have these like false presuppositions. So of course the model would get it wrong because there's no right answer. Another concept is the idea of implicatures. So implicatures are things that are suggested by an utterance, though they're not actually literally expressed in what you say. So this is somewhat related to entailment, but in this case, it's only suggested. It's not like a literal truth that has to come out of that statement. So for example, I could say something like looking out the window, I see it's lightly raining and like muggy and kind of gross. And I say, oh, today's weather is the worst. Now, when I say that, I'm not saying that it's like the literal worst case scenario of the weather, right? Like it could be like there could be a tornado or a hurricane. That is obviously way worse than light rain. But what I'm trying to express and what is implied is that it's bad, I don't like it. Another thing in conversation is like indirect answers to questions. So maybe someone came up to me and was like, oh, did you vote? And my answer could be like, oh, I was sick on Tuesday. Like, what is implied by that statement when I say something like this? Anyone? Right, I didn't vote. However, I could add on additional information to my response. I was sick on Tuesday, but I voted anyways. So unlike entailments, which we saw earlier, which are going to be true, implicatures, which are just suggested by an utterance, can be defeasible, which means like I can add something onto it and like negate that implicature. So it's nice that we have all these like concepts on like, oh, maybe I'm gonna suggest something. Oh, like maybe that suggestion can be like completely devoid. But how do we actually conduct conversation and achieve like that effective communication? Like, what are the implicit agreements in our conversations that allows us to actually use language effectively? And Grice thought about this quite a bit, and he came up with these 4 principles. And he has this assumption that people are rational speakers and that they expect and follow certain constraints. So the 4 that he had come up with is quantity. People generally don't like massively undershare or overshare information. They will generally tell the truth when you ask them a question. They'll generally be relevant to the topic at hand that you've agreed upon. And in the manner of that conversation, they're going to be clear. They're not going to convolute what they're trying to say. However, because we're all like social agents and have had numerous conversations, we know from personal experience that these things don't always hold. They may not hold either like intentionally for different reasons. So for example, you can flout maxims by using things like sarcasm, irony, hyperbole, where you're like maybe stretching the truth or like saying things in a funny way that like changes its manner to be something that's a little less clear. But you're doing this with the intent that the listener actually understands the underlying implicature. On the other hand, you can break maxims covertly with the intent that the listener never knows your actual your intention by violating a maxim. So instead of like using hyperbole to exaggerate, you might just outright lie, use a half-truth, or overcomplicate things. So one thing that's great about language, but also makes it very difficult to deal with, is that there are oftentimes multiple ways of saying the same meaning. How do we actually choose which one of these options is the best one to choose? We can do various things like pick between different grammatical structures. We can change our intonation and stress patterns. We can like swap out one word for another, etc. And I think a large part of what we do implicitly depends on the speaker and the listener's knowledge of common ground, their communicative goals to the listener, and then also what they think is desired by the listener. So I have a couple of fun examples to illustrate this. Like imagine I am like someone who has no knowledge of NLP. I go to Miami next week. NLP is hosted somewhere downtown. I'm just at a cafe. I want to enjoy my like Cuban sandwich. And I look over and there's a bunch of researchers saying how they're going to launch a bunch of small llamas, right? Like that is nonsensical to me. It doesn't make any sense. It's because I don't have a common ground with those speakers. Another example, back to wanting to put salt on food. Like imagine I'm like a chef in a high stakes scenario in like a very busy kitchen. I might like yell salt to my really stressed sous chef to like have an urgent command of like, oh, give me the salt now. Versus in a different scenario where I still want salt on my food, I'm like calmly at a dinner table asking my friend if they could please pass me the salt, and they pass it to me very slowly and relaxed versus salt, you know. Another one is stress patterns, which we haven't talked about as much, but I think is really cool because it spans like the whole spectrum of different abstractions we talked about earlier. So consider the sentence, I train llamas. Depending on what word I put stress on, I can answer different questions depending on what the listener wants from me. So let's say someone asks me, oh, like who's the one training all the llamas in your group? I could be like, oh, I train llamas. Someone might also ask me like, maybe they're not familiar with the idea of like llamas as a model. They're like, and they were the one overhearing this conversation and they're like, what are you doing to llamas? And I'll be like, oh, I train llamas. Versus, what are you training? Like, you were talking about training earlier, like what is the thing that is being trained? And I can say, I train llamas. So all of these things like in text are exactly the same, but depending on how I say it, I'm answering different questions. I'm changing the focus depending on what information has been requested or I believe has been requested by the listener. So one nice computational approach to pragmatics is this idea of rational speech acts. It's a Bayesian model of communication, and it views communication as like this recursive reasoning process between a speaker and a listener, where the speaker is trying to infer what the listener believes, and the listener is trying to infer what the speaker believes they believe, and all the way like multiple levels up. Now, for those of you who might be a bit more familiar with the space, what does this concept remind you of? Does anyone have any ideas? It's another concept from psychology, also pretty popular in NLP evaluation these days. Anyone have an idea?
Theory of
Yeah, it's pretty closely related to theory of mind. So to give like a very, very simplified rundown of RSA, we can consider the setting of a reference game. So here there's a listener and a speaker, and the speaker is trying to convey which one of these three icons they are referring to. Basically, we have this set of possible states, and imagine you have a fixed vocabulary of utterances to refer to one of these three states. In the literal, or in the base case, which is that innermost bubble, the listener is literal, and it's only going to consider one of these three options based on the thing that the speaker has said without any context. One level above that, when choosing what to say to the listener, the speaker is going to think about the potential interpretations that the listener has, and it's going to choose the utterance out of the set of finite vocabulary that it has, such that the listener is most likely to infer the correct world state given that utterance. And then one level above that, the listener is going to reason about the potential states of the world, so these like three options, given an utterance by the speaker with the assumption that the speaker is trying to be maximally informative. So like this listener here is thinking about the speaker, and the speaker has said, my friend has glasses. Well, if they wanted to refer to like the one with the hat, which also has glasses, maybe they would have said, oh, my friend has a hat instead. So it's like this reasoning process over like, why would they pick that utterance? Oh, they're going to pick that utterance because they're picking the one that has the highest probability of me picking the correct answer. And then we can like pop up these levels of bubbles however many times. And like the way you would think about this is like my thinking, what you're thinking, I'm thinking that you're thinking, et cetera, et cetera. So we're kind of running out of time, which is why there's like a whole list of things that I think are really interesting in the overlap between linguistics and NLP that remain to be studied. So if you have interest in any of these topics, I'd encourage you to read more about it. Especially these days, there's a lot of open questions in applied fields like neurolinguistics, psycholinguistics, sociolinguistics is a really big one, and typology. One question that I'm personally interested in is that, humans seem to be really data efficient. How can we imbue that in models? How do humans learn to generalize from like a limited set of exemplars? And can we how can we create language models that do the same thing? Another thing from the viewpoint of evaluation is how can we design fair comparisons between human and language model competence in terms of how they are processing language or like quote unquote understanding language. And then related to like sociolinguistics being an ever-growing area that overlaps with NLP, a huge question is how can we make NLP systems work better for everyone, including people who speak non-standard dialects and marginalized languages. And then from an analysis point of view of the field, who are the people that current NLP systems leaving behind and why does that happen? And I think that is everything I have for today. So